Hey everybody, let's talk a little bit about acid-base theories. And so there's a ton of acid-base theories around, but we're going to first start talking about Arrhenious theory. And Svante Arrhenius was around, and he was like one of the first people to really figure out the chemistry behind acids and bases. Excuse me. So let's spend a little bit of time talking about, I don't know why I have the hiccups. Maybe it's because I'm drinking my Coke Zero. Okay, share a Coke. I'm sharing it with you guys. That's what. Anyways. So let's talk about this. Let me get rid of my face, and then let's go. Okay, so Arrhenious theory, named after that guy Svante Arrhenius. And Svante Arrhenius noticed that acids are compounds that increase the hydrogen ion. Okay, now, when we think of hydrogen, and I'm going to tell you this is vocabulary that you should know, is that a hydrogen ion, remember a hydrogen atom has a proton here and an electron, but the ion has lost the electron, H+, and so sometimes we will call this a proton. Okay? Hydrogen ion is synonymous with proton. I think that that's one of the very first vocab things that you should know. Okay? And so what ends up happening is that compounds that have hydrogen listed first are things that donate protons. Okay, so HCl is an Arrhenious acid. HNO2 is an Arrhenious acid. HSO4 is an Arrhenious acid. This is what I will call the ionizable hydrogen. Okay, or the ionizable proton. If you have a compound like C6H6, that H is not an Arrhenious proton. It's not an Arrhenious acid, okay, because it's not out in front, okay. And so Arrhenious is kind of the easiest. The Arrhenious acids are kind of the easiest to understand, and because of this. And so there's actually, Arrhenious bases, and again, those guys are pretty easy to see because there's a hydroxide floating around out back. Remember, hydroxide polyatomic ion OH-, and we can figure out the formulas of all these guys. But these guys are bases because they increase the hydroxide ion concentration in water. And so I think that that's neat too. Arrhenius came up with this theory really just based on hydroxide and protons. Now, we have to realize that this theory really just talks about how solutions are affected by an acid or a base. Okay? So, in order to be an Arrhenious acid, you must have an aqueous solution of the compound. And so HCl gas is not an acid based on Arrhenious theory, but HCl aqueous is. And that's because we have a solution, and therefore we are looking at how the acid and also base, if it were some other base, would be affected. It's all about how the solution works. And the kind of the explanation that I have that's really maybe a little graphic, but in World War I they used mustard gas, which was kind of a version of HCl. And so the gas would come out, and it wasn't really, it was yellow. It was a different thing, but when it hit and turned into a solution, by breathing it in through your lungs are coated with water, and so, and other things. But the water, when it mixed, then it would turn into the acid, and that's when you would probably literally cough up your lung. So, so gas in Arrhenious theory is not a solution, is not a acid or a base, has to be aqueous. Okay, and so water is kind of unique using the Arrhenious theory, and this is very important when we're dealing with this. Okay, water is what we call amphoteric. There are several compounds that are amphoteric. It can be either an acid or a base. But water, if we have several water ions, water can dissolve in itself. And so water, and I draw it like this instead of H2O. So one of the things that you'll see is sometimes I will draw water like this, because water will split apart and it will form H plus and OH minus. And so it forms this guy equally, because how many of these? For every one of those, there's one of those. So that means you got one of those and one of those. So for every one water, you get one hydrogen ion and you get one hydroxide ion. So it's like water is kind of this really interesting compound that can dissolve in itself to produce both hydrogen ions and hydroxide ions. And so this is, and we'll talk about this later, this is why water is kind of in the middle of the pH scale at 7 when it's pure water. We're like, hey, pure water, great. We don't think of pure water as having hydrogen ions or hydroxide ions, but it does. Okay? So water, this is also called the auto-ionization. Okay? Water ionizes in itself. Auto, self, ionizing. Okay, so I think that that's really neat. There are other theories. We're going to talk about other theories a little bit later, but I wanted to make sure that you understood what Arrhenious theories were. So there you go. Have a great day.